Good day, good day. Welcome to Yebo Tutor live stream help on this beautiful Monday. I hope you are all doing well and I hope you are all enjoying and you are managing properly. Uh, it's a beautiful day that we've met once more again. Come on in, come on in, come on in, come on in, come on in. Today we're gonna have a special edition. We'll be doing Euclid functions, which are so crucial in your maths paper 1. They contribute plus or minus 35 marks. So today we'll be polishing on our functions. Hashtag road to final exams. I think you are less than 20 days left before your final examination for the year 2022. I wish you all the best as you are preparing. Don't hesitate to ask any question on the WhatsApp group. And if you're not on the WhatsApp group, don't hesitate also to join on our WhatsApp group. The link is in the description of this video, and you can also call on Zoom and you can catch us live and we can chat and interact together and have a nice time together. And also don't hesitate as well to comment on the comment section, because the idea behind everything is for us to have an interactive session and to be able to assist each other in a great dynamic way. Yebo Tutor live stream help, coming to you live from Nelson Mandela University, CBC, in the physics department in South Campus. I hope everyone is doing great. Now let's jump into the content of today. So today, as I mentioned, that today we'll be doing functions. So on the function which we are doing today, I want to highlight what is so crucial, what is important, which include the following, that you must be able to understand that on functions it carries it will say that it carries plus or minus 35 marks. So these are the marks for functions. So on the functions, just to do a quick recap, we once mentioned this. So if you want the total background of functions, do look on the video for functions on the website. It's available as well. Great. So now in functions, we mentioned few things which are so important. So let me just remind you right now. Let me just say, note well. Okay, let me remind you. Let's just say not well. So the first thing which is important is that we have different functions which we will be doing, which you are dealing with, which include, the first one is a straight line, which you're taught in grade 8, grade 10. Then the next one is a parabola. Then the other one is a hyperbola. And the last one is an exponential function. So those three functions, they are so crucial. The first one we say is the straight line. It's the straight line. The second one is the parabola. Then the third one is the hyperbola. Third one is the hyperbola. Then the fourth one is the exponential. Great. So these are four functions which we really look at in our grade 12 syllabus. So just to go fast, on a straight line, the equation of a straight line y is equal to mx plus c, or I love this one, y minus y1 equal to mx minus x1. I love this one because it will give you the depth understanding, and it's just going to lead you straight to an already formulated equation rather than the other one. So I love this one a lot because it's straightforward. Then on a parabola, y is equal to ax squared plus bx plus c. This is in the standard form, as you can see, that ax squared plus bx plus c. So on the parabola, just to give you a quick recap, we know that we must be able to understand and to be able to calculate the turning point of the function, since it's a parabola. So in order for you to calculate the turning point, you know that we use the formula x is equal to negative b all divided by 2a, so that you can get the x coordinate of a parabola. And your parabola can either be looking down or looking up. So others will explain and say it's happy or it's smiling, others it's like it's sad. So it's so crucial that you must be able to determine the turning point on the function. So now after you get the x value, you must be able to calculate the y value. So y is equal to 4ac minus b squared over 4a. So this is the formula which you use to calculate the value of of the y-intercept of the turning point. Or after you've calculated the x value of the turning point, substitute that x value straight into the original equation which you have been given. And bear in mind that on parabolas, sometimes they will ask parabola in different ways, or they can give you the function in different ways. For instance, the first one, they might give you in the x-intercept formula. So in this instance, they are just giving you 2x-intercept and the value of a. So in other words, you have your x-intercept already, and you're also given the value of a. And bear in mind that the value of a is the one which determines whether your graph is going to be looking down or is going to be looking up. Now, also on our parabola, we highlighted the fact that when we are dealing with parabola, we might also have to know what we call the turning point formula. So the turning point formula now is now the one which we use the turning point. So the turning point, let me just write it down. So the usual love this. So y is equal to a x minus p all squared plus q, where p and q, they are the value of the turning point. Then after that, you can be able to get your turning point formula. Now, sometimes they will ask you to determine the turning point formula whilst they have already provided you with the standard formula. So in that case, or in that instance, what is supposed to be done with you is that you now apply your skills of x, whereby now you are supposed to complete the square. Okay. Oh, someone will be like, okay, how about I calculate my my turning point points, then after that I substitute there, then after that I'll substitute the value of a, because the value of a is always the same. If the standard form had the value of a to be 1, also here on the turning point formula, the value of a is still going to be 1. So you can calculate in 2 different ways. Great. And the last thing about the parabola is that sometimes they may ask you what is the axis of symmetry. So the axis of symmetry is now just easy, that you just have to calculate the x value of the turning point. Then after that, you have your x value, and now you can conclude that's the axis of symmetry. Now moving forward to our hyperbola. So our hyperbola, it's y equal to a over x minus p plus q. So now on a hyperbola, we have what we call the asymptotes. Okay, so we have what we call the asymptote, and the asymptotes, they are so crucial because the graph is not supposed to touch the asymptote. So in other words, what are the values of the asymptote? So x will be equal to p and y will be equal to q. Bear in mind that value of p, if for instance you're given -2, which means the x value of the x asymptote, it's going to be positive, and if we're given positive, it's going to be negative, because if we equate this denominator and we equate it to 0, then we solve for x, then therefore we can see that x is equal to p. So if it was x plus p, when we equate it to 0, you can actually see that your x now begot negative p. So please pay careful attention to that fact. Now also, what is also important on this hyperbola is that you must be able to determine also the axis of symmetry, and it's just easy that always y is equal to x minus p plus q. This is for the positive gradient, which is the gradient which is illustrated by the small letter m. When it's positive, then therefore you can use this. So you can actually see that it's just x minus p plus q. But if they want for the negative gradient, so your y now will be equal to negative, then x minus p plus q. Then now that's how you get your axis of symmetry for the negative gradient. Now also on the hyperbola, it's so important to be able to plot the hyperbola, because in order for you to plot the hyperbola, you just have to know the x and the y intercept, then you plot your function. So what is also important in this is that now we will have our horizontal and the vertical asymptote. Okay, so y is going to be your horizontal asymptote and x is going to be your vertical asymptote. Then after that, you'll be able to plot your function, and make sure that when you're plotting your graph, it should not touch the asymptote. Now moving forward to the last one, which we highlighted and say that is called the exponential function. So this one is the last one which you'll be looking at in your syllabus. So this one is just quite almost easy. You must be able to solve your exponents. So the concept of solving exponents, which you were taught when you were solving for x, I think it's grade 11 stuff. So you must be able to solve for exponents, to be able to equate exponents, so that you can be able to formulate the equation for the exponential function. So y is equal to a times b to the power x plus q. And now the exponential function only have one asymptote, which is the horizontal asymptote. So when you're plotting this function, it has the horizontal asymptote, which is q, which is, this is when the q is negative. If q is positive, it will be above the x-axis. Then after that, you can plot your graph, and bear in mind that always the case that doesn't change in all the functions, the hyperbola as well as the exponential function. Make sure that you don't plot on the asymptote. Make sure that's always the key. Then also you must be able to use the log functions. That's great of work, which is just generally easy because you must be able to apply the exponential function, and now you can use the exponential function to find the inverse, and the inverse will be the log function. So if for instance you are given point A, which is 1:2, so on the inverse now it's going to be A, but now it's going to be 2:1. So this is what we mean, and this is how we apply our log function. So this is so great that we must be able to understand this concept because it's quite straightforward and direct, and it's going to lead you to get high marks. Bear in mind that this is plus or minus 35 marks. So make sure that you take care of those marks. Okay, let's get down to the business of the day. I was just giving you an overview to remind you. And if you need more explanation, don't hesitate. On the channel, you just click on the channel there and you search functions. You will see the video which I was explaining and just doing step by step and explaining each and every concept about functions. So now let's look at November 2021, which is the past question paper which was written last year, and let's look how the functions were looking like last year. And bear in mind that you can still ask your question on the comment section. I can see, then I'll be able to respond to your question. Right now, let's get to the business of the day. So now, as we can see, that this is November 2021. Last week we did analytical geometry, so today we are doing paper 1. Analytical geometry is paper 2, and you can see it's 150 marks. So what I would advise now is you are now preparing for your exams. If it's 4-mark question, practice that and make sure that you solve that problem in that 4 minutes. If it's a 2 marks question, don't exceed that 2 minutes, because 150 marks is 3 hours. So you can actually see that it's approximately like 2 minutes a question if you like try to calculate it. So make sure that the marks go hand in hand with the minutes you're supposed to spend there. All right, now let's go down to the business of the day, which is question number 5. So on question number 5, what do we have there? So on question number 5, we are given f of x, which is equal to -1 over x minus 3 plus 2. So that is what we are given. So when we look at that format now, definitely we already know what's going on, for the fact that we're given f of x is equal to -1 over x minus 3 plus 2. So that's a hyperbola. So before you analyze or before you answer a question, analyze it first and collect the information which you know, so that you can go fast with the question. For instance, this one, you can definitely say that this is a hyperbolic function. So you must now already collect in your mind, okay, on the hyperbola, I must know my horizontal asymptote, I must know my vertical asymptote, I must know that they might ask me the axis of symmetry, I must also know my domain and the range, so that I can be able to plot my graph in a proper way. So in other words, the moment I know my range, the moment I know my domain, I'll be able to plot my function in the correct way. So that's the basic things which are so crucial when you are plotting your hyperbola and understanding the concept behind hyperbola. So now let's look at question 5.1. So 5.1, they ask, write down the equations of the asymptote of f. Great. That's already straightforward, because we knew when we were reading our given, we knew that this is a hyperbola, and already the format of a hyperbola doesn't change. So always the hyperbola, the way they'll give you equation or the function or the formula or the equation of that function, it's always the same. It doesn't change. So let's answer together. Let's answer together. The equation of the asymptote. So our x will be equal to +3 and our y is equal to 2. Okay, where is x equal to 3 coming from? We say that we're gonna look at the denominator here. So since it's x minus 3, we equate it to 0. Then we solve for x, then our x is equal to 3. So this is where x is equal to 3 is coming from. Then now we say that for the y is equal to 2. And bear in mind that x is always the vertical asymptote, then y is always the horizontal asymptote. Now let's look at the next question. Let's look at the next question. Write down the domain of f. So the domain, I always say, and I always highlight the fact that the domain is always, we are looking at the x-axis now. So on the domain, we can see that our function will be x is the element of real numbers, because it will start from negative infinity to positive infinity. And now we can actually see that it doesn't have to touch the asymptote. So this is the most important part, which must understand that on a hyperbola, the graph must not touch the asymptote. So since it's supposed not to touch the asymptote, that makes our life so easy, because now we already know that, okay, when we are determining our domain, x is definitely the element of real numbers. But now we must highlight that x must not be equal to the asymptote, which is equal to 3. Then after that, you'll be able to have the correct one. So this is our domain. So in this instance, they didn't ask for the range. So if they ask for the range, so you're just going to say y is the element of real numbers, where y is not equal again to the asymptote, which is 2, which is the horizontal asymptote. So this is the range and this is the domain. So I just went further and gave you the range, even if they didn't ask, so that maybe this year they will ask the range and not the domain. So please always know that the domain of a hyperbola is always x element of real numbers except the asymptote. Because bear in mind, when I was explaining earlier, that I say that when you're plotting a hyperbola, your graph must not touch the asymptote. The moment it touches the asymptote, which means your graph is wrong. So also that will mean that your domain will be wrong. So please make sure that the moment you have your domain right, your life is already easy already. Now let's move forward. Now on 5.3, determine the coordinates of the x-intercept of f. So just write this down, x-intercept. When you're writing this down, so you are making the examiner to see that, no, you know what you're doing. You know what you're doing, x-intercept. Now, after that, you just write, just simple English, you just write x-intercept, so that you show the examiner that, no, I know what I'm calculating, okay? So you just write x-intercept. Then how do we calculate the x-intercept? Always, we know that we must let y be equal to 0. Then now let's go. Where is our equation? So we're given f of x is got negative 1 over x minus 3 plus 2. So definitely we know that our f of x is equal to y is equal to negative 1 over x minus 3 plus 2. So this is the function which we are given. So in order for us to calculate the x-intercept, we say that we let y to be equal to 0. So this position already, it's 0 is equal to negative 1 over x minus 3 plus 2. Then after that, now we solve for x. Now we transpose that positive 2 to be negative 2. Then it's equal to negative 1 over x minus 3. Then after that, we now apply our algebra skills. Then we cross multiply there. Then we have negative 2x minus 3 equal to negative 1. Then after that, this will be negative 2x. Then negative 2 times negative 3, that's going to be positive 6 equal to negative 1. Then after that, negative 2x is equal to negative 1 plus, minus 6. Okay, negative 1 minus 6. Then after that, we can actually see that it's negative 7. Then you divide by negative 2, divide by negative 2. Then, therefore, our x is equal to 7 over 2, which is approximately 3,5. Okay, so this is our x-intercept. So you can even write it in a coordinate form, so that you show that, no, you know what you're talking about, and you are determining the x-intercept. So definitely when you're determining the x-intercept, the y value is always, and it's supposed to be 0. Then after that, you are done, and in life is nice. Then you get your full marks, and I think it's 2 marks. So you get those 2 marks. So you can actually see that functions, they are not hard, they are easy peasy. All right, now let's move on from that question. Now we are on 5.4. Write down the coordinates of the y-intercept of f. So earlier they asked us to write down the coordinates of the x-intercept, and we said that we let y to be equal to 0 because we want the x-intercept. But now we want the y-intercept. So again, please don't hesitate, just write this small English, that y-intercept, so that we know what you are doing, and then underline it. Okay, network also, it's just great if you have network. It shows that you know what you are doing. So y-intercept, then we let our x to be equal to 0. Then now let's go to the equation which we're given. So we're given that y is got negative 1 over x minus 3. So wherever we see x, we will place 0 now. So now we will have y is equal to negative 1 over 0 minus 3 plus 2. Then our y will be equal to 1 over 3 plus 2. Then we use our calculators. Don't crack your head. That's why you have your calculator. Your calculator is there to save your day. Then you will have 7 over 3. 2 marks, 2 minutes. 2 marks, 2 minutes. 1 mark, 1 minute. Don't spend more time because you must finish writing your exam. That's the idea behind everything. You must finish to write your exam. So if it's 2 marks, make sure that you don't spend more than 2 minutes on that equation. Then now we write it again as a coordinate, because definitely when they're asking us the x and the y intercept, definitely the next question they'll ask us, plot your function. So when they say plot your function, already written your x and the y intercept in coordinate form. So now you just have to go on your graph and you just plot it on your Cartesian plane. Then you have your function in a proper way. Now the next question, draw the graph of f, clearly show all the asymptotes and intercepts with the axis. Wow, that's great. That's great. Now we've already have all the information. We know the asymptotes, we know the x, we know the y intercept. What else do we want? Nothing. Now let's just go and plot our function. So sometimes they'll just give you this question for like 7-mark question. They just say plot the function. They won't ask you to determine the equation of asymptote. They won't ask you to determine the x-intercept. Don't worry about anything. The moment it's a hyperbola, know that you must have two asymptote, the x and the y asymptote, which is so crucial when you're plotting your graph, because if you don't have those two, you won't be able to plot your graph in a correct way. And also you must also know that, okay, this is a hyperbola, I must know my x and the y intercept. Then after that, you are done with your life. Your life is already easy for you. Now we are just going to the Cartesian plane and we are plotting. Okay, so let's plot together. Let's plot together. So this is our x in axis, this is our y. Now great, so what is our asymptotes? So before you plot anything, before you put the x and the y intercept, we start with our asymptotes, because your asymptotes are the ones which direct you to plot your function in the correct way. So our asymptote where x is equal to 3 and y is equal to 2. So let's go down to our function. So just put 1, 2, 3, 4, and it's ended 5, negative 1, negative 2, negative 3, negative 4, negative 5, positive 1, 2, 3, 4, and 5, and 5, 1, 2, 3, 4, and 5. Okay, then also we have negative 1, negative 2, negative 3, negative 4, negative 5. Great. So we start with our x-intercepts, our asymptote. So our asymptote, we say that its x is equal to 3 and y is equal to 2. This is our asymptote. So y is equal to 2 is the horizontal asymptote. Where is 2? Here is 2. So here it will be our horizontal asymptote. For just doing that, you already have your 1 mark. Just to plot that and just write y is equal to 2. It shows that you know what you're doing. Then x is equal to 3 is our vertical asymptote. So we come here again, we plot our vertical asymptote. Your life is already easy for you. So this is x is equal to 3. Then we know that our x-intercept, it was 7 over 2, 0. Then the y was 0 is to 7 over 3. It was 0 is to 7 over 3. What is 7 over 2? 7 over 2 is 3,5. So 3,5 is somewhere here. Then the other one, it's 7 over 2, 7 over 3. So what is 7 over 3? 7 over 3, when we use our calculator, that's approximately 2,33 when we use our calculator. So it's somewhere here. So 2,3 is somewhere here. So you can actually see that our function is going to be in this quadrant. And also it's gonna bear in mind, when you are plotting, it is not supposed to touch the asymptote. Whatever you do, let it not touch the asymptote. Be careful, because the asymptotes are meant for that not to be touched. Then this is my function. 3 marks, 3 minutes. You get your marks, you move forward. So just to recap again, in order for you to plot a hyperbolic function, you must know your vertical as well as your horizontal asymptote. And also you must know your x and the y intercept so that you can be able to plot your graph in the good way. Then now after that, when you're plotting, you start by putting the horizontal and the vertical asymptote so that you can actually plot your graph in a correct way. Then after that, you get your 3 marks just like that. 3 marks, 3 minutes. So this is our motto for this exam. The marks which are allocated is the same amount of time which you're supposed to spend on that question. Don't spend much time because time will leave you and you won't be able to finish the paper. The idea behind everything is for you to finish the paper. Then we are done with question number 5. You go with your 10 marks. Now, question number 6. Now we're moving forward to question number 6. It's also functions. Question number 6. The graph of f of x, equal to log 4x. So we're given our function, given f of x is equal to log 4 of x. Given our function is log 4 of x, and is drawn below. Then we're given coordinate point B, as you can see, which is k is to 2, is a point on f. It's a point of f. So now you can see that, okay, it's a point of f. Then let's move forward. Let's hear what they are saying. Let's hear what they are saying. Calculate the value of k. 6.1, calculate the value of k. So how do we calculate the value of k? That's also not hard because we are given the function. All right. So now what do? We are given that y is equal to log 4 of x. So now we just substitute point B, which is k is to 2, in the equation. Then this is x, this is y. Of course, we know that this is a coordinate. So wherever you see x, we put k. Wherever you see y, we will put 2. So it's going to be 2 equal to log of 4k. Then according to the rules of log, so that's going to be 4 raised to the power of 2 equal to k. Then 4 squared, it's 16. So then therefore your k is equal to 16. This is you applying your laws of exponents and also the logarithm law. So this was just straightforward. This was straightforward. I hope everyone understood that part. Now let's move forward. Now let's move forward to question number 6.2. That was 2 marks and we didn't even spend 2 minutes on that. So what is also important when you're writing exam, even if it's not maths, you must be time conscious. Okay, please make sure that you manage your time properly because the idea is for you to finish the paper. Now determine the values of x for which -1 is less or equal to f of x is less or equal to 2. So how do we determine the values of x? So I would love to do this. So now this we can actually say this is like a what do we call this? This is like a an inequality. Yes, this is like an inequality. So since it's like an inequality, now we can just play around with everything which we have. Okay, so now initially we can actually start by saying that if x is equal to, or let me just say if f of x equal to -1. Okay, let's do this. Okay, so we start by saying if x is equal to -1, then after that we do this. Now let's calculate the value of x. So we know that the function of x, f of x is now f of x is equal to log of it's now log of 4 to the power x. Okay, so now if f of x was -1, what's the value of x? So we now substitute -1 is equal to log of 4 to the power x. So this will be 4 to the power -1 equal to x. So then our x will be equal to 1/4. Then the other one, if f of x is equal to 2, then This means that 2 is equal to log of 4x, then 4 squared is equal to x, then our x will be equal to 16. So now we can actually see that our x is 16 and our another x is 1 over 1 over 4. So that's easy, because now we're already just gonna come and jump in and just substitute 1 over 4 is less or equal to x is less or equal to 16, because we calculated the x value when f of x is equal to -1, and we also calculated the x value when f of x is equal to 2. Then after that, we just went back to our inequality check they have given us. So just like that, you get your marks just like that. I hope that you understood that question. It was just a matter of you understanding that you are given this interval, which is the interval in the form of f of x. So now we must just calculate the x value at this point of f on this y value, and also calculate this point at this y value. Then after that, you just write the inequality again, then you get your marks, then you get your 2 marks just like that. Let's move forward. Let's move forward. Okay, now on the next question, write down the equation of f -1, which is f inverse, the inverse function of f, in the form of y equal to. That's amazing. That's amazing, because the questions, they are always the same. So let's write down the f inverse. So we know that we are given that y is equal to log 4 of x. So in order for us to plot an inverse function, the first thing we do is straightforward. We know that 6.3. We know that the first, you swap x and y. Then after that, we solve for y. So 4 to the power x is equal to y. Wow. Then therefore, the function will be y equal to 4 to the power x. This is the inverse function. Just like that, then you have your marks. Let me repeat again. So since we were given y is equal to log base 4 multiplied by y, so by x, sorry. So the first thing, when you're determining the inverse function, we swap x and y. So where there was x, you put y, and where there was y, you put x. Then after that, you solve for y. So that's the same concept which we use there, that we had y is equal to log 4 x. Then now we just swapped x and y. So now we have our x now on the left hand side, and now we have our y on the x on the right hand side. Then after that, we solved for y, then we raised that x up, then we applied our log rules. Then after that, we end up having our log 4x to the power 4x is equal to y. So that's the function they are looking for. Then we get our full marks. We'll be awarded our full marks for being able to see that. Then now doing the last question of question 6, which is 6.4. Now we're doing the last question of question 6, which is 6.4. For which values of x will x multiplied by the inverse function be less than 0? So they're saying that for which values of x will x times f inverse of x be less than 0? Okay, let me just show you something like sort of like a trick. If we have x multiplied by 4 to the power x is less than 0, then definitely you can actually say that x will be less than 0, or also 4 to the power x will be like also less than 0. So this is like 4 to the power of x less than 4 to the power of 0. So drop down, then x will be less than 0, and also x is less than 0. So your answer is x is less than 0, just like that. So someone was going to solve it, someone was just going to use or go to the graph, or at the same time, then be able to see it. So I would advise, so that you make sure that your answer is bit correct, or advise you for you to calculate it. You can actually see that x multiplied by f inverse of x is less than 0. So what was this? It's 4 of x. So then we multiply the two. You can actually see that x is less than 0, or 4 to the power x is less than 0. Then now we solve this. We can actually say that 4 to the x is less than 4 to the 0. Then after that, we get our x is equal to 0 there. Then we have our full marks. Then we can actually conclude. So on 6.4, the last question, it didn't need many things. 6.4, it didn't just only needed you to just write that x is less than 0. Then you get your marks on that question. We are moving, we are cruising nicely together. I'm seeing others are also joining. They are there. Please just type something as you are listening. Just type something. Seeing there's Teboho, nice one. Thank you so much. I'm seeing that we have people joining us. That's great. That's really amazing. Now let's move to the last question of the day, which is question 7. Now we are doing question 7. Now we are on question 7. So on question 7 now, that's the the tough one, the one which needs some people to think. So question 7, the graph of f of x is equal to x plus 4 multiplied by x minus 6 is drawn below. The parabola cuts the x-axis at point B and D, and the y-axis at point G. Hope we can see that, all of us. So what is important is to be able to analyze the question. Be able to analyze the question before you calculate anything. I highly advise analyze your question first. Then after that, you can be able to calculate whatever you want to calculate. Everything lies with you just analyzing the question. So now the graph of f of x is equal to x plus 4 multiplied by x minus 6 and is drawn below. The parabola casts the x-axis at B and D. So in other words, the coordinate of B, already we know it that B is going to be equal to x comma 0, because B and D, they are the x-intercept of the function f of x. For the fact that they say the parabola cuts the x-axis at B and D, so automatically we know that B is a coordinate which is x comma 0, and also D it's x comma 0, and also they told us the y-axis is G, so also y-axis is G, which means our x will be 0, so it's going to be 0 comma y. Now, they also told that C is the turning point. So in other words, definitely must know how to calculate that turning point, because I've already told you earlier when we were starting the session that in order for us to calculate the turning point of a parabola, we say x is equal to negative b over 2a. Then after that, when we get that x value of the turning point, we substitute it back into the original function so that we get the y value of the turning point. Then now the line AE has an angle of inclination of theta. So line AE has the angle of inclination of theta. Now, wow, this is great, because last week we were doing analytical geometry, and analytical geometry is the one which deals with the angle of inclination. So what do we know about angle of inclination? We know that tan of theta is equal to the gradient of the line. So in this instance, in order for us to know that theta, which is the angle of inclination, we just have to know the gradient of point AE. So you can actually see that, okay, we have not yet looked at the question, but we are analyzing the question. So it's so crucial when you're doing maths to be able to analyze, to have that mindset of being able to analyze the question, because the moment you'll be able to analyze the question, that's the moment you're going to have your answers. All of them, they will be correct. So now line AE has an angle of inclination of theta, and it cuts the x-axis and the y-axis at A and E. So at A, this line AE is cutting at point A, and you can actually see that A is on the x-axis. So also point A, definitely it's already given. We already know the coordinate of point A, it's x comma 0, because it's on the x-axis, and also E is the y-axis. So in other words, it's going to be 0 comma y. So always just write those things which down before you even answer question. Then T is a point of L on F between B and G. So we can actually see that T is between B and G. Definitely you must be able to calculate that point. So now let's go down to 7.1. Write down the coordinates of B and D. Wow, we have already answered them when we were analyzing our question. So that's why it's so important to analyze the question before you attack it. Before you attack someone, you must know who you are dealing with, so that you can have everything in control. You just don't go and attack something without having the full knowledge of what's going on and, like, surveying the place. So before we answered our question, we started by analyzing what we are given, what we know, and what we are given in the information. So now 7.1, Maths Made Easy by Yebo Tutor for you. So 7.1, write down the coordinates of B and D. So we say that B and D, they are the axis. So definitely that's already a given. So initially we know that we are given f of x is equal to x plus 4, and also x minus 6. So now they are asking us to calculate or to write down the coordinates of B and D. Now let's write them down. Great. So this is the function. So we know that B is the x-intercept and also D is the x-intercept of the function. So now we will just let our equation to be equal to 0. Then after that we solve for x. So if we do that, we will have 0 is equal to x plus 4, then also x minus 6. Then now let's solve for x. Then x plus 4 is equal to 0, or x minus 6 is equal to 0. Then our x will be equal to negative 4, or our x will be equal to positive 6. Then now what you just have to do is just to look at your graph. Okay, which one is negative, which one is positive, which one is on which side, which one is on which side. So looking on our graph, we can actually see that D is positive, is on the positive side. So automatically now we'll just conclude and say, therefore B will be negative 4, 0, and D will be then D will be 6 is to 0. So these are the coordinates, 1 mark, 1 mark. So that was just straightforward. From the equation which we were given, we just calculated the x-intercept of the function. Then we were able to know the coordinates of B and D. So if we're not able to analyze that B and D were the x-intercept of the function, we were not going to be able to realize that B and D, they are just the x-intercept, which just have to be calculated first, because we already know one coordinate, which is, we already know the y coordinate of the point B. So that was going to be hard if we didn't analyze it initially. So that's the benefit, or that's the crucial thing of analyzing the question initially. Then on 7.2, calculate the coordinates or determine the coordinates of point C. 7.2, determine the coordinates of point C. So we know that point C is the turning point. They told us point C is the turning point. So how do we calculate the coordinates of a turning point? We already told that, we already said that x is equal to negative b over 2a. But in this instance now, our problem is that we are given this in x-intercept. So y is equal to x minus 4, and also x is plus, yes, it's x plus 4, then x minus 6. So let's solve this and put it into standard form. So that will be x times x, x squared, minus 6x plus 4x minus 24. Then it's going to be x squared minus 2x minus 24. Okay, 4 minus 6, yes. So our function in standard form, it will be x squared minus 2x minus 24. That now will lead us to be able to calculate the turning point. The x point of the turning point, we say x will be equal to negative b over 2a. What is our b? Our b is negative, so it's going to be negative 2 multiplied by negative, sorry, it's going to be negative of negative 2 divided by 2 multiplied by 1. Then that will give us our x coordinate to be positive 1. So this is the x coordinate of the turning point. Then now, in order for us to calculate the y coordinates, now we just substitute in the original equation by that one. In other words, we want y is equal to f of 1, which is equal to, so that's easy because that's 1 squared minus 2 times 1 minus 24. Then we get 1 squared is 1, 1 minus 2, it's negative 3, negative 3 minus 24. Let me check again. It says 2 times 1, so 1 squared it's 1, 1 minus 2 it's negative 1, negative 1 minus 24 it's negative 25. So then therefore our point C will be 1 comma negative 25. So we are done. So also again, since we were able to read the statement and understand that, okay, point C is the x-intercept of the function, point C is the turning point of the function, definitely that led us not to spend much time thinking that, okay, point C, we're not given point C, how are we going to do this? Since we're able to analyze it, we were able to get the correct answer quick and fast. And you can see it's 1 mark question. So 1 mark is 1 minute. 1 mark, 1 minute. 1 mark, 1 minute. So always know that 1 mark is 1 minute. Now let's push now, write down the range of f, which is 7.3. That's easy as well, because now we say that the range of f will be looking at the y axis. The domain will look at the x axis, then the range, you look at the y-axis. So now we want to determine the range of f. Now we know the coordinates of the turning point. So the point C has the y value, which is negative 25. So then therefore we can actually see that y must be greater or equal to negative 25. That's where we'll be able to find our graph. It must be greater or equal to negative 25. Or someone will say that y is the element of from negative 25 to infinity. So you can write this. One of these two formats must give you the same correct answer. You can actually see that our point C is the greatest y value. So that will be easy for us to be able to determine the range, because the range, we are looking at the y-axis of our function. So we'll be able to realize that y must be greater or equal to negative 25. Or someone will say that, okay, y is the element, then you put our included bracket, negative 25 to infinity. So one of these two, they are all correct, and you'll be awarded full marks as well. You'll be awarded full marks as well. Let me check. Let me check. Thank you so much. I'm seeing the interaction. That's great. That's what we are looking for us to be able to interact. Thank you so much. Thank you so much. Now let's move forward to our question 7.4. Let's move forward to question 7.4. Given that theta is equal to 14,04 degrees, or theta is the angle of inclination, please don't forget that is the angle of inclination. So, and the tangent to F at T is perpendicular to AE, and the tangent at T is perpendicular to AE. Now calculate the gradient of AE correct to 2 decimal places. Calculate the gradient of AE correct to 2 decimal places. That's straightforward, guys, because last week we were doing together analytical geometry. So since we're doing analytical geometry, we know that on 7.4 we know that the gradient tan of theta is equal to the gradient. So now what is the theta? We are given that theta is 14,04 degrees. Then that must give us the gradient of line AE. Then therefore the gradient of line AE will be equal to, now just press your calculator, tan of 14,04, what is it equal to, so that we get the gradient. So the gradient, when we use our calculator, I'm using mine, and I got 0.25. This is also like 1/4 when you write it in a fraction format. Then 7.4.2. Now on 7.4.2, the question goes as calculate the coordinates of T. So T, they say that initially they gave us the information that given that theta is 14,04 degrees and the tangent to F at T is perpendicular to AE. So this is amazing, because now we know the gradient of line AE to be equal to so the gradient of line now is now going to be easy, because now we can see that they are perpendicular bisectors there. So we can actually realize that, and now we used our format of calculating the perpendicular bisectors according to analytical geometry, that gradient of the radius multiplied by the gradient of the tangent is equal to -1. So now, since we are not talking about the radius here, so we definitely know that when we multiply these 2AE and also for the one for T, since they say they are perpendicular to each other, they must give us -1. So it's going to be 1/4 multiplied by the gradient of tangent is equal to -1. So then gradient of the tangent will be equal to -1 divided by 0.25. Then we get our -4. So this will be our gradient. Now let's determine the the equation of the tangent. So when we were doing calculus, which we are going to do also next week, we know that in order for us to determine the gradient, we know that the first derivative of a function is equivalent to the gradient of the function. So then therefore we can actually say that since we are given f of x to be equal to x squared minus 2x minus 24, then f prime of x is equal to 2x minus 2. Then this is our f prime of x. Now what is this f prime of x? F prime of x is this gradient, which is equal to -2. So the fact that we already know that our gradient is -2 is going to make our life easier, because according to our calculus, we know that the first derivative at this specific point is equal to the gradient of the function. So great. So now we just substitute -4 is equal to 2x minus 2. Then -4 plus 2 is equal to 2x. So 2 minus 4 is -2 equal to 2x. Then we divide both sides by 2, divide both sides by 2. Then our x will be equal to -1. Then our x will be equal to -1. So this is the x coordinates of the point T. Now we need the y coordinate of point T. That's easy, because now we just substitute our xt, which is equal to -1, into f of x. Then therefore we can actually see that when we substitute there, it's gonna be yt now is equal to -1 squared minus -1, 2 times -1, sorry, yes, it's minus 2 times -1 minus 24. So that will be 1 plus 2, 3 minus 24. Then we get negative 21. So then therefore the coordinates of t will be -1 is to -21, just like that. So just to recap again, the first thing which we did, since we're given that the gradient of line AE and the gradient which is going to pass through that point T, they are perpendicular to each other, we multiplied both of those gradients. They are equivalent to -1, because we know that they are perpendicular bisectors. So now we got the gradient of the tangent. Now we know also, according to calculus, that the first derivative at that specific x coordinate is equivalent to the gradient of the whole function. So since we know that, now we just apply that. Now we start now and we just equate it. Then we get this x value of the tangent. So after we get the x value of the tangent, then we substituted that one into the original function which we were given. Then after that, we get our y to be -21. So now we can conclude that t is -1 is to -21. Then the last question of the day. Last question of the day. 6 marks. Wow. A straight line G, 7.5, 6 marks, which means 6 minutes or even less than that. A straight line G parallel to AE. Wow, that term parallel, we need it. There is something about parallel lines which we must be able to apply it now. So for the fact that this line is parallel to AE, which means the gradients, they are the same. But okay, let's proceed reading. Let's proceed reading. The analysis is so crucial. The analysis is so important. The fact that you heard that term parallel, your mind must run fast. Okay, parallel lines, they have equal gradients. But okay, it's fine. Let's proceed reading to see what they want from us. Then they say that it cuts f at k, -3 is to -9, and r. Calculate the x coordinate of r. Now we must calculate the x coordinates of r. That's amazing, because what is important is to understand that the gradient of this line, which we are talking about now, gradient of line AE is equal to the gradient of this line which we want. Let me just say this line is equal to 1/4. Why are you saying that, Vian? Because they are parallel lines. And what do we know about parallel lines? Parallel lines, they have the same gradient. You see, we have already analyzing this, and we're analyzing it in a great way. Now we're just gonna apply what we know. Now we know the gradient of this line KR. Now what is important now, let's determine the equation of that line. So we know that again, that y minus y1 is equal to mx minus x1, where y1 and x1 is a coordinate. So for instance, in this instance, we were given our coordinate k, which was equivalent to -3 is to -9. So we can just substitute that coordinate in this equation. So it's going to be y plus 3 is equal to the gradient, which is 1/4 x. Then it's plus 9 this side. Then here it's going to be plus 3. Then after that, we solve for y is equal to 1/4 x plus 1/4 plus 3/4 minus 9. Then we use our calculator. Don't stress yourself for things that in your control. Just use your calculator. That's why you go to exam with your calculator, because they know that your calculator is the masterpiece. It makes your life also easy, and it's going to make sure that you don't waste much time on one thing. So 3 over 4 minus 9, when I'm using my nice calculator, I'm getting negative 33 over 4. So this is now the equation of that line K and an R. Now we can see something which is important, that this point R is on both the function f of x and this new line. So we can actually see that, oh, okay, no problem, since they are on the same function, and we can see that it's like a point of intersection. So since like a point of intersection, don't worry, because we know that the point of intersection, those two lines must be equal on that point. So what do? Easy, we just equate both of them, then after that we solve them first. So we just say f of x is equal to this equation of this line. So x squared minus 2x minus 24 is equal to, what is our y? Our y, it's 1 over 4 x minus 33 over 4. Now let's solve for the x values. So our x squared minus 2x minus 1 over 4x minus 24 plus 33 over 4 is equal to 0. Then after that, we can actually realize that if we solve this properly in a nice way, we must be able to get the equation, because we're just going to multiply everything through by 4, so that you can like have normal numbers. So we have 4x squared minus 8x, because this 2 multiplied by 4 is going to be like 8x. Then 4 multiplied by this, that's going to be like 96. It's going to be like minus 90. Let me just do this so that we don't waste much time. So if we multiply all through by 4, we will get 4x squared minus 8x minus 96 is equal to x minus 33. So we can actually see that we multiplied all through by 4, so that we can have like normal numbers. Then we have 4x squared minus 9x, then 96, negative 96 minus 33, we get negative 33 equal to 0. Then now this is now an algebraic equation. Then if you don't know how to find factors, I advise that we use our algebraic equation, which says that x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. So you can use this, or you can just find factors. So if you are able to find factors like me, you can actually be able to see that it's going to be x, then positive 3 there, then we have 4x here, then we have negative 21, and after that, those are our factors. Then we solve for x, then our x will be equal to 21 over 4, or our x is equal to negative 3. Okay, so now definitely we can see that, therefore, in this function, our x can never be equal to negative 3. So we're only going to use x is equal to 21 over 4. Then from that point, we can actually see that we can just substitute x is equal to 21 over 4 in the line equation. So then therefore we can find the y value to be, y is equal to, what was our line equation again? 1 over 4 x. So where there is x, now we put 21 over 4 minus 33 over 4. Then we use our calculator from that part. Then we can get the y value of the equation which they want. Just double check again. So they only want the x coordinate of r. They don't want the whole coordinates. So this part is not really important. But if this year they will ask like the whole coordinates of r, this is now, you just put that 21 over 4 in this equation. Then after that, you'll be able to get your value of r and have the two coordinates of point r. That will be really, really great. I hope you really enjoyed our live stream today on this calm, warm Monday. So today we were doing functions. So it sums up grade 11 and grade 12 work. So I hope you really enjoyed. I'll try to send this question paper in the WhatsApp group. So if you're not in the WhatsApp group, please go in the description of this video and click that link, then join the WhatsApp group so that you can able to receive our materials when we are handing over to other students. And you can also access us 24 hours, anytime, anywhere, and you can be helped. Till we meet again, have a great evening, and don't forget to subscribe if it's your first time to come. Don't forget to drop your comment. Don't also forget to share with friends so that they can also be assisted. Till we meet again, continue practicing, continue preparing for your exams. This is your last time for you to do your grade 12. Just push and push and push. Till we meet again, have a great evening.